Alright, so let's now get into sound pressure level, decibels, and frequency. So these are going to be three important measurements that we'll refer to in the course, but the main one being dBFS. You have Decibels SPL, which means decibels sound pressure level. You have decibels full scale, which is written as dBFS, and you have LUFS, which is loudness units relative to full scale. There's many more measurements in the world of audio, but we won't get too deep into the weeds here. We'll just stick with these three. The sound waves produced through speech travel at the speed of sound, which is very fast, and the louder the sound, the higher the air pressure will be, and that air pressure is measured as sound pressure level, which we write down as dBSPL, decibels sound pressure level. So dBSPL is a way of measuring the power of a sound in relation to the human ear, because the human ear can hear a certain range of sound pressure levels. Comfortable range of hearing in humans is about 20 dB to 80 dB, so 0 dB is where the measurement starts. Below that, humans can't hear anything. Above 80 dB, it's going to be loud. In some instances, it might be uncomfortable getting above 80 dB. So around 120 dB is maybe like a rock concert. That's how loud it will be in terms of sound pressure level, which is the amount of air pressure. So that was decibels SPL, dBSPL, which is air pressure measured in a physical sense and how loud the sound will be. We won't refer to that much. Microphones have SPL ratings, so you'll be needing to know about it there. Decibels is an important measurement that you're going to be encountering a lot in your podcasting journey. We'll just go over the measurement of decibels now, and I'll try and explain it. It is kind of confusing, so we don't want to get into the mathematics too much. But generally speaking, the way sound works, sound pressure level, it takes more and more power and increase air pressure to produce the same perceived level of increase in sound in humans. So each 10 dB increase on your chart is representing a number that is to the power of 10. So it's representing a times 10 multiplication in each advancing stage. When we look at these two charts here, we see the one on the left is how air pressure gets measured in a linear fashion in real life. We see once it gets to a certain point, it takes a lot more air pressure to produce the same perceived increase in loudness in humans. The chart on the right represents after we apply a logarithmic scale and use decibels as a measurement, the line becomes straight and it's much easier to interpret the numbers in that case. So each 10 decibel increase on the y-axis, which is the decibels, represents a 10-fold increase in the intensity of sound. We'll leave it there because we don't want to get too complicated, but essentially, yeah, you're making a number with lots of zeros and lots of numbers on it, just be represented as a smaller number. The decibel compares two numbers that differ by many digits and represents the ratio of those numbers with a smaller, simpler number. Decibels are logarithmic. They allow simple numbers to express values that would normally require many more digits.